Okay, today on the bench we have a radio that's been blown up. So this was sent in to have some repairs and modifications done to it. It is a realistic, I hope I got the radio here so you can see it. It's a realistic DX-398. It's a shortwave radio. I've got think at least two, maybe three of these. I do like these little radios. They're really nice. One of them that I own, I actually purchased brand new from Radio Shack back in, God, the early 90s, I think. I've had it for a long time. They're great little radios. Now, they do have one problem, and that's probably the main reason this radio was sent in for repair. You can't hear it now. After I get done doing all the work to this, I may hook it back up so you can actually hear it. But the audio on this thing is just, it crapped out. It sucks. There's no easy way to put it. It is a known problem with these radios. That problem is the speaker. These speakers are known to go bad, and they'll cause that problem. So if you have one of these radios and your audio has just gotten to the point where it's unbearable, it's just so distorted and it's just almost unintelligible, you probably have a bad speaker. Very easy to replace. Couple screws, speaker comes up and out. I mean, there's a little bit of glue around here you sometimes have to cut to get it out, but they're not too bad to replace. He asked while he had the radio here if I could also recap the radio, because it's getting old. It's getting up there in age. This thing's over 20 years old, so it's just a matter of time before all of these electrolytic capacitors all over this board are going to start causing all kinds of havoc with all kinds of circuits. So it's one of those, it's in the shop getting some other stuff done. Might as well do it while you have it, Mike, so it's getting done. Now, these can be a little tricky to get apart to this level without breaking anything, I should say. Now, the cabinet itself comes apart fairly easily. Now, actually, this was made by, what was it, Sangen. Gree made a lot of shortwave radios for Radio Shack, but Sangen also made them, and this one is a Sangen-based radio. They were also sold by, who the heck else had these? I think Roberts, and I think Siemens had, they all look the same, just different, basically, just like CB radios, same case, different name. But I think Siemens and Roberts also made these as well. But to get the main cabinet apart, so let's say you're just replacing the speaker. There's a couple screws on the outside. Now, fortunately, they were nice enough that any screw that has to be removed from this to get this case split apart is indicated by an arrow. See the little arrows right there. Honestly, you don't even need to look for arrows. If it's a screw on the back, take it out. There's not many of them. There's only, I think, 5. Yeah, 1, 2, 3, 4, 5. So you've got those 4 really long screws and 1 short one. So it's 1, 2, 3, 4, and then the short one's down in here. Take those out. Now, the case is still going to be a little tricky to get apart because there's also some plastic fingers that interlock these halves of the, the two halves of the case together. So kind of set it on a table there, kind of pry it apart a little bit. I'll usually take something like one of these little tools you use for splitting cell phones and like tablets and whatnot apart, but just slip that down in there and just slowly walk that down and pop the case apart. You'll eventually get usually about to here, and blink, it'll just fall apart into 2 pieces. The speaker, like I say, you'll have 2 wires. Actually, they're right there, where the wires that were soldered to the speaker. And if that's all you're doing, take out the 2 screws, pull your speaker out, put your new speaker in, solder the wires back on, and put the 2 halves of the case back together, put your screws back in, and you're done. If you need to take it apart even further, so let's say you want to get, because I'm also going to be doing what they call a cuffing modification. Anybody that's used a shortwave radio. Now, CBers probably aren't familiar with this, and honestly, most amateur radio operators may not be familiar with this problem. But in the shortwave radio receiver industry, a lot of these radios have what's known as cuffing. So while you're tuning the dial, it mutes in between every step. So every time you see a digit change on the display, you'll hear, so like when I was talking, it would cut out in between every detent. on this rotary encoder here, it cuts out, it mutes. That again, extremely simple to correct that problem. Let's see, it's not this board that's marked, it's this one. We'll get to this. I need to be really, really careful down here so I don't break any of the wires off of this ferrite rod antenna. But just turned around. So if you look down here, now when you take the radio apart, normally it's going to have this big plastic piece over top. I had to take all of that the right direction. No. Yeah, like that. It was on like that. Now I have to take this off because I'm changing the electrolytic cast, but normally this would be on like this, and then this module is sitting down on here. So on this board, there's only two little screws. That's these little small ones down here, which I put a little paint dot just to remind myself exactly where they go. But you take those two screws out, but you want to be careful. That's not the only thing holding this plastic piece to that board. You've got a little spring finger. There's one right there, one right there, and then there's three along the bottom side edge. You want to carefully pry out. That's why people often say, Mike, you got long fingernails. Trust me, actually my fingernails are a little bit too short right now. I like long fingernails because they're tools. It's not a cosmetics thing. I like my long fingernails. I use them on a daily basis as tools for stuff like this. But what I'll do is I get my fingernail wedged underneath of the circuit board, and then you just gently pry out on these little plastic fingers and start popping the board out. But be careful, don't push out too far on these. Now, this plastic's still good and pliable, but over the decades, plastic does become brittle eventually, so just, be careful when you're working on stuff like this that has plastic retaining fingers. Don't think of it like metal, where you can just fold that thing back out of the way and push it back later. Yeah, you go too far with this, it's going to snap off. But once you have that pried out, the board is still going to be attached to this board with these three cables, okay? They just unplug. Now, if you've had batteries in your radio, when you unplug this board, now it's dead now, but when I first took this out, it still had the time on here and a battery indicator. It was disconnected from everything else. That's because it does store some charge in here, and that's to store memory. But when you fold that board up, what you're looking for is this connector right down here. So the bottom right hand edge, okay? That mates up to this cable right here. And you'll see both of these cables have a black wire, okay? What you want to get to is the one that's labeled CN2 for connector 2. And you'll notice right there, well actually it's upside down, kind of hard to read upside down. If you look right there, you can see every single pin is labeled. This bottommost pin is labeled mute. If you cut that wire, which just happens to be the black wire here, if you cut that black wire, that disables mute, which is exactly what happens when you're turning this rotary encoder. It mutes in between every frequency step when you're turning this. Cut that black wire, it basically turns it into an analog receiver. Because right now it acts like a digital receiver. Every time you turn, it mutes, goes to the next frequency, audio comes back on, you turn it to go to the next frequency, it mutes. When it gets there and locks on, it unmutes. If you cut that black wire, it removes that mute function, and it functions much more like an analog receiver, where you can just sit there and spin the dial, and you can hear the sound as you're changing frequency. Because it's so hard to tune these things. If you're a band scanner, or you really like to spin the knob, trying to find some traffic to listen to, I'm not going to say it's impossible, but it's really hard with radios like this, because when you turn that knob or push the channel up-down buttons, it mutes in between every single frequency step, and it's annoying. Very annoying. Now, one word of caution, if you're going to be taking this off of this bottom main board, be really, really careful. Again, of course, it has all these little locking fingers the whole way around the perimeter. You'll see them where they're around the edges, and some of them even go through the board. So yeah, be aware there's little slots you can see in the board there. There's little plastic fingers go up through there. But again, get these two pieces separated. You'll have to desolder the positive battery wire there. But the thing you want to be careful about is your ferrite rod antenna, okay? This antenna right here. You want to be really careful with that, not to break or rip any of those wires off. That is trapped in here. Okay, so it pushes in there and then snaps down in this end. So you can see again we have a little kind of a springy plastic finger, but there's glue on here. So take a knife or something, I just use a dental tool that I have sharpened up, and I break that glue loose and then take that antenna out. But be really careful, and I can pretty much guarantee as soon as you take this out, all of the glue that is holding these wires that come up off of the board on to the ferrite here, so they don't unravel. All that glue, you can see it's dark brown. Yeah, it's been on there since the early 90s, so it's pretty much dried out and done its job. It's going to break loose, and it did just that on this one. So what I do is I take a piece of Scotch tape, 3M, doesn't matter what brand you use, but I take a piece of Scotch tape to make sure I'm holding the wires pretty much in the position they need to be, and I apply some new glue. So I've actually applied some 3M go-to glue down in there. That has cured now, but now I don't have to worry about all of these wires coming unwound off of that ferrite rod antenna. So now the next thing I'm actually going to do is I'm going to temporarily hot glue this to the circuit board, because I don't want this thing flopping around, because I've got all of these caps to change. Luckily, where you can see the ferrite antenna is there, there's no electrolytic caps right here. So temporarily I can just put a big blob of hot glue right there, big blob of hot glue on the other end, set that ferrite bar antenna down onto it, let it cool down, and that'll hold that there while I'm working on the circuit board, and I don't have to worry about ripping any, because trust me, if you've ever had to rewind one of these things, it's a pain in the butt getting it exactly like the factory had it. So yeah, do everything you can to avoid damaging those little tiny wires there. But yeah, like I say, just a little bit of hot glue, and then when I'm done and I'm ready to put this radio and reassemble it, I can just apply a few drops of isopropyl alcohol. Don't ask me why, not a chemical engineer, but isopropyl alcohol breaks the bond of hot glue like that. You just put a few drops on there and you can grab this thing and blink, it'll pop right off. Where normally you'd probably break the ferrite trying to get it off. Yeah, isopropyl alcohol is great for doing stuff like this, getting hot glue off. And that's why I use hot glue. It's really strong, so I don't have to worry about this falling off, but I can easily get it off after the fact. So there you go. You can take a look at the board there. Like I say, lots and lots of electrolytic caps, man. They are just crammed into this thing. I'm also going to take off the glue there. This stuff, just like most of the glues that they use in consumer level products, it's eventually going to become corrosive and conductive, and it's going to eat everything that it's touching and eventually short out circuit traces. Do not remove the wax. I see people occasionally, maybe not on radios like this, but on CB radios, I'll see people remove that wax off of the circuit boards. Bad idea. The factory put that wax there for a reason. It has multiple uses. It can hold parts in place. Usually they're using it for either temperature stability or to make stuff anti-vibration resistant, so it can help to absorb vibrations. They're going to use wax, like in a CB radio, and in the case of this radio, they're using it in parts of the frequency synthesis, so oscillator circuits, where the tiniest movement of a piece of wire can change frequency, because by it moving, it's going to vary its inductance and capacitance with all the other surrounding parts around it, so they want to hold it very, very steady. It also helps to stabilize temperature, so they'll very frequently pot stuff like varactor diodes and other parts, or even the crystals themselves sometimes. They'll pot those in beeswax. That way it can help to stabilize the temperature. So if there's a really quick temperature swing, let's say, the crystal or that part in there isn't changing at a really drastic rate. It has to slowly warm up that whole block of wax, and it can hold its temperature, at a more constant, and more stable temperature. So let me get to it. Like I say, lots of caps to replace on this thing. Man, they're just dense. I mean, wow. There's probably as many caps in this little shortwave receiver only now. This thing does not transmit, but there's probably just about as many caps in one of these as there is almost in a lot of sideband, AM sideband CB radios. So, like I say, really nice little radios, though. I've got a couple of them. Like I say, I've been using one since I bought it new in the 90s. They were really well-built little radios. Like I say, had a few inherent problems. I've done the cuffing modification on all of mine, because that's the first thing I do. I absolutely despise that every time you change frequency. So let me get to it, and when I get back, what I'll do is, once I get it recapped, get everything reconnected, I will temporarily reconnect the factory speaker so you can hear what this sounds like. Because like I say, very common problem. People think there's something seriously wrong with their radio, and that it's going to cost a lot of money to fix. And honestly, something like this, you want to spend a lot of money on it, or you throw it in the trash can and buy a new one. It's not going to cost you a lot. Matter of fact, if that's your only problem, it's probably just the speaker, and you can fix that yourself. 5 cabinet screws, you pull those 5 just slightly out of view, 4 long, and 1 short screw out of the case, split it apart, pull 2 screws out, pop the speaker out, pop a new one in. You can fix the problem yourself. But like I say, once I get all this other work done to it, I'll put it back together so you can hear what the defective speaker sounds like. So I shall return. Oh, and one other thing. Is it financially practical, honestly, to recap one of these radios? That depends. If it's my radio, yes. Well, I'm doing the work, so I'm not going to charge myself. I mean, I have to buy the caps, but it's not going to cost me anything. But when, a customer's radio, a lot of people will ask that. Why did somebody pay to get this thing recapped? Is it worth it? They could have just gone and bought, if one of those caps, let's just say a cap's gone bad. The caps are going bad in this, let's say. And they'd say, well, yeah, but somebody could go buy another one. And, that works fine for less than what it's going to cost for you to recap the radio. And I'm also going to do not a transceiver, I'm going to do a receiver alignment on this as well. That's going to cost a lot of money because there are several hours worth of work here. That's up to you, the person that owns the radio. You either want to get it fixed or you don't. If you like the radio, it's, what do you say? I mean, you look at prices on anything old. It's worth as much as somebody will spend on it, honestly. If somebody's willing to invest the money to restore it, and you have to remember, now once it's been restored and you put all new caps in it, this thing's going to be good for several decades again before it's going to have problems again. So, me personally, I like fixing stuff like this a lot of times just because this older stuff is built better than the modern junk that they're manufacturing. So, and I'm not sure, was this made in China or Japan? I'm just looking at the back cover here. Receiver, manufactured in Taiwan. But that's actually a step up from it saying made in China. Back when stuff was made in Taiwan, they were kind of the higher end market, compared to made in mainland China. So, but yeah, like I say, a lot of times it's worth restoring the older stuff because it just works better. Sometimes it has better features than the modern radios, better build quality. Not only that, if you've owned one of these things for 20 plus years, you've probably gotten really used to it, how the functions, because you can see there's a lot of buttons on this thing, there's a lot of features to it. You get accustomed to using something like that. You don't want to learn how to use a new radio. So again, it's probably, yeah, go ahead and get your radio fixed. But that's up to you, the owner. That's not my decision. And when people ask me, Mike, was it worth it for somebody to get that thing repaired? That's not a question for me to answer. That would be a question for the owner. Was it worthwhile for them to pay me to repair their radio? And obviously the answer was yes, it was worth it, or they wouldn't have paid me to restore their radio in the first place. So, in any case, let me get to it, because I'll never get this done if I keep talking. Okay, so just really quick before I change the speaker in this and put it back together. So as you can see, all the electrolytic capacitors have been replaced. I wanted to show you what these speakers sound like when they're bad. So I have not replaced the speaker yet. So I have it on medium wave or AM radio. Yeah, that's horrible. That's actually the station I listen to most of the day, 1090 in Baltimore. Yeah, and the stronger the signal gets and the higher the volume gets, the worse it sounds. So if you have a radio that sounds, one of these little radios, Like I say, it can be a Sangen, Realistic, Siemens, or a Roberts. If it sounds like this, there's probably nothing wrong with the radio itself. You just need a speaker. So let me get that popped in. I still have to do the alignment on this, and once I get that done, I'll get her put back together, and we'll see what she sounds like when she's all back together. Okay, so I got her all back together now. Definitely sounds a lot better. Actually, let me unplug that. I had a external speaker plugged in. Now, even with a new speaker, you have to realize, tiny little speaker, you can only get so much fidelity out of this tiny little thing. So these do sound tinty. Doesn't matter what speaker you stick in this thing, it's going to have a fairly tinty sound to it. If you want to do some serious shortwave listening to this thing, or anything listening, I always recommend using an external speaker, and this is no exception. Currently, I just, after reassembling it, did a master reset on it, so it just has a little reset button there in the bottom, and I've put it on 10 megahertz. Now I have a GPS locked reference oscillator right there that's at 10 megahertz, so yeah, I have a huge 10 megahertz signal just continuously 24 hours a day, 365 days a year in the lab here, because that reference oscillator goes to a distribution amp. So yeah, there's lots of 10 megahertz signal. So I've got the antenna down, completely retracted, and it's on 10 megahertz. So if we go to lower sideband and actually turn the volume up, you don't hear anything other than a little bit of static. Switch to upper sideband, don't really hear anything. So it has, and the reason I do that is that verifies that once I've completely reassembled the radio, the oscillators are still aligned correctly. So the frequency is dead on, and you can see if I change the frequency, actually might need to put the antenna up just a bit. And switch to the other sideband. You can hear there's nothing. Go up. So that's all you should hear when you switch between AM upper and lower sideband on a radio. If you have injecting a carrier frequency at whatever frequency you have your radio set to, you should basically hear dead silence. That means your oscillator is aligned correctly. So let me extend the antenna up the whole way. I don't think it'll run into the ceiling. Okay, it's still got about 2 feet to go. It is a fairly long antenna, which most radios like this do have. Even though it's a little small radio, they do have fairly long antennas. Now there's not really going to be much. Let's just plug in the external speaker. Well, here, I'll just demonstrate the radio. Let's go to FM. So if I plug in an external speaker, you can hear the, and it doesn't matter where I stick the tone switch on this, it continues to have that fairly tinty sound to it. I don't want to play it too long, copyright or whatever on music on the radio, so I'll turn it down every once in a while. But if I plug in an external speaker, you're going to hear the difference. I'll have to turn the volume up because it's a fairly large speaker over there. It's a Kenwood speaker. And make sure I have that in the medium or normal tone. And then if I unplug it, yeah, get a lot better bass response out of a bigger speaker, as to be expected. And this radio does have the RDS system, the radio data system. So when you get to a station that has, which I think 98.5 has that, doesn't it? Maybe not. I can't keep track of which stations brought. Oh, yeah, it does. RDS. Just popped up on the screen, and it flashed off. Yeah, move the antenna a bit. There we go. But you can see it's reading the, just sends small packets of data, the RDS system, to show you, like, call sign of the broadcaster. A lot of times they'll actually show you the name of, you know, the band and the song that whatever's playing on the radio. So this does have that.
Rocky 98.5, where classic rock lives. I'm not trying to his gratitude. .com. If I can find happy. The song comes slipping through the
And that right there, I know for a fact where that transmitter's at. That's in downtown Baltimore, and I'm just over the Pennsylvania, Maryland, Pennsylvania state line in Pennsylvania. So you can see I'm picking up 98 rock. That's what that is. Very good signal strength. These are really good little receivers. And if we get down to, God, trying to think what the heck is it, 89 or 9? No, it's 89.9 maybe. Yeah, there it is. That's the local college just across the state line from me here in Emmitsburg is Mount St. Mary's College. They have a little radio station they run.
Surpasses more to my life were Avengers.
That's what we use.
There's Iron Man.
So, like I said, middle of the day, shortwaves really sucks right now. Probably the best way to put it. See if we can get anything on any of the... See, I doubt we're going to get anything on any of the bands right now. Maybe we'll get some broadcast on the short wave, but it's not going to be anything like if it was the middle of the evening, anytime but now, basically. So I picked the absolute worst time to turn on a radio. Actually, I think what I'll do is I'll wait actually until the conditions are a little bit better for actual shortwave listening, and I'll film actually a little bit of shortwave listening on this radio, because like I say, they're actually very good little receivers. It's surprising how well a radio this small works. Now, don't be mistaken and think you buy something this small and you're going to get the performance or the features that you will out of a full-size, high-dollar shortwave radio. It's not that. But for what it is, these little radios work really good. And actually, there's a lot of them. It's not just this radio of this model. Realistic had lots of them over the years. There's Grundig, Eaton, Siemens, Roberts. I mean, there's lots of even CC Crane makes radios. There's lots of companies out there that make these little shortwave radios. And if you've ever been interested in shortwave radio listening, something like this is a good thing to start with. You can pick up something used like this, especially if you can find one that has that crappy sound. You now know what the problem is. Bad speaker. That's all you need to fix it. So, if you can pick up a broken one or one that has that crappy sound, somebody thinks the radio is shot, you can pick it up for a couple dollars, pop a couple dollars into a speaker, throw a new speaker in it, and you've got a perfectly good working radio. Now, remember, these are older. Like I said, I've got a couple of these myself. For the life of me, I can't remember when I got mine. I was thinking early 90s, but it wasn't the early 90s. I think it was the late 90s, early 2000s probably when I got them. I bought one for myself. Actually, I've got two of them. One that I bought for myself. I bought two of them at the same time. One for myself and one for my father. And then when he passed away, I basically got that one back. Kind of inherited it back. And then I think I have a third one. The two original ones that I had recapped and aligned several years ago. Now, I did have this radio turned on and listening to it before I did the alignment on this. I tried it out, and then I did the alignment, and yes, sensitivity definitely picked up. So, now the alignments on these is not for the faint of heart. Unfortunately, the design, you saw how it's double circuit boards in there. All of the test points for when you're doing the alignment on this thing are on the back of that big board, the big main board that sits in the back there. All the adjustments are on the front. All of the test points are on the back. So you almost need to have, you're going to need an external power supply plugged into the board, because you have to have the back plastic portion of the radio pulled off so you can get to the test points. It's just a pain in the butt. Also, if you want to do a full complete alignment on one of these, you have to remember this has FM, so you're going to need an FM stereo MPX signal generator to do the alignment on this. So actually a lot of test equipment you need to do one of these to do it properly. But you can look at the service manual with basically nothing more than that right there. A small and a large alignment tool. You can actually do a good bit as far as AM and your sideband receive sensitivity just by ear. No test equipment whatsoever. And a lot of radios are like that. You don't need test equipment. As long as you've got halfway decent hearing and a couple tools, you can just wing it by ear. Is it going to be perfect? No, absolutely not. But you can get it better than it probably is after, a 20 to 30 year old radio. Things to look for when you're looking in the service manual would be your sensitivity adjustments. So let's see, clock, indicator, battery level. Now, this one's kind of important. You really need a frequency counter to set this one properly. This one will mainly, is going to affect upper and lower sideband accuracy. So these two adjustments, where I was showing when I had it set to 10 megahertz and I was flipping between upper and lower sideband, if you have some way of producing a frequency, so if you can produce, even if, honestly, if you have another little radio that you can turn on, you can use the oscillator circuit in even a little transistor AM radio, a little cheapy thing, and just lay it underneath of this radio. Basically what you're using is the oscillator circuit in that radio, and then zero beat the oscillator in this one. They tell you to do it with a frequency counter to adjust your upper and lower sideband oscillator circuits, but you can zero beat that. It takes a little bit of practice and experience, but that is one way to get around this without a frequency counter. But let's see, FM, honestly, I wouldn't touch anything in the FM circuit unless you have a stereo FM MPX signal generator. You're probably just going to screw it up if you don't. Now here's where you can you can usually pick up some receive sensitivity with nothing but some alignment tools, and that's really all you need. You get into the AM, the oscillator circuits, especially when you get into the AM sensitivity, you'll see there's usually lots of adjustments in the AM sensitivity. This is where you can pick up a lot on your receive sensitivity just by ear. Just pick a really weak station, set the radio, turn it on, set it to receiving a really weak station. Ideally, you should do it somewhere around the frequency that they have set, because what they're trying to do is they set it in the middle of a tuning range. But so they tell you 15.1 megahertz here, so you can tune around that frequency, but try to find a frequency close to 15.1, something you're listening to. And even the static background noise, you can tune it just listening for the static for maximum noise. Ideally you don't want the noise, but it's still, you can pick up, actually increase your sensitivity by doing that. But yeah, look for things like that. Your AM sensitivity, even the 450 kilohertz trap circuit, you can adjust that by ear. Bass frequency, in this radio, I wouldn't screw with that. Wouldn't screw with the... No, actually, I probably wouldn't suggest doing that. You don't want to do that. And that's about it, I think. Yeah, so, AM... upper and lower sideband adjustments, you can usually improve with nothing but a couple alignment tools. A little bit of practice, so again, it comes into experience, practice, but in a good ear. You'd be surprised what you can do with no test equipment whatsoever. But yeah, like I say, I'll set this off to the side, move on to the next radio, and then probably later on I'll turn this back on when the shortwave's booming in, and we can actually do some shortwave listening and see how this thing works. And again, you have to remember, where I'm filming this right here, I'm basically in an RF vacuum. I'm basically sitting in a Faraday cage. I'm surrounded by big metal filing cabinets, parts cabinets, a wall of test equipment. It's just, yeah, the only way signals get in and out of this room are through the roof or through the floor. That's, up through the bottom, through my feet, or, coming down straight out of the sky, because I've just got so much metal around me. But, so I'll be back, and actually I want to set this back up, reset the, location, the time zones, and set the time for the customer on this thing. I'll pop a new. Right now I have a set of my rechargeable batteries in it, but I'll pop a new set of regular alkaline batteries in it for the customer. But once I get all that set back up, so I'll be back and we can do a little bit of listening later on.